Good morning, my YouTube viewers. It's Crystal here. I haven't been making videos in a few days because I've been studying, trying to work on my skill set, improve my skill set. But yesterday I finished a project on some web development that I'm working on, and I decided that I wanted to work on some natural language processing. And since natural language processing is done in Keras TensorFlow easily, I decided I would do a program with some tweaks on natural language processing with Keras. So the first thing we're going to do before we look at the code is we're going to talk about what is LSTM, that's long short-term memory, and how does it work in NLP. So natural language processing tasks frequently employ a recurrent neural network variant known as long short-term memory. RNNs are natural networks that process sequential data such as time series data or text written in a natural language. A particular kind of RNN called LSTMs can solve the issue of vanishing gradients, which arises when traditional RNNs are trained on lengthy data sequences. Collection of memory cells that can store information and transmit it from one time step to the next make up LSTMs. A system of gates that regulate data flow into and out of the cells connects these cells. The input gate, forget gate, and output gate are the three different types of gates that make up an LSTM. The input gate governs the flow of new information into the cell, and the forget gate regulates the flow of information out of the cell, and the output gate manages the data flow into LSTM's output. By controlling the flow of information this way, LSTMs can forget information that isn't important while remembering other information longer. LSTM has been used in many natural language processing tasks. And then here's an example of some of the processing tasks. And what we're going to do today is, I think we're going to do text classification. In NLP, LSTMs are typically trained to classify the overall meaning or sentiment of the text, or to take a sequence of words as input and predict the next word in the series. These NLP tasks are good fit for LSTMs because they can handle a sequential data well and keep track of previous inputs in memory. LSTMs can retain information for a long time while forgetting irrelevant information. Bidirectional LSTMs are another LSTM variant that helps maintain the context of the past and future when making predictions. So that's basically what LSTM is, and it goes in longer talking about more things about LSTMs, which you can read on your own if you want to, because you've got the website address, so you can look at that if you want to. I'm not gonna set it up. Gonna dismiss it. Now what we're going to do is we're going to do the actual code. I have a data set that I got off of GitHub of some tweets, and we're going to use that data set of the tweets. So the first thing that we need to do is we need to create our program, and we're going to write a program in Google Colab, which is a free online Jupyter notebook hosted by Google. So the first thing that we want to do is we want to import our libraries. And then when you import the libraries, the first thing that you need to do is you need to import all of the libraries at the very top of the program. That's the standard procedure. I know I haven't necessarily done that in the past, but I'm trying to do it the way it's supposed to be done. And the way it's supposed to be done is all of the libraries are imported at the beginning of the program. So we're going to import NLTK, that's Natural Language Toolkit, and we've got that done twice. Just take that out. And then we're going to import pandas, which creates your data frames, and it processes the data. And then I just open pandas automatically at the beginning of every program because you may need it. We're going to import NumPy as MP, which it creates NumPy arrays, and then it creates NumPy arrays, and then it makes numerical computations. So I always just import pandas at NumPy and NumPy whether I need it or not. And then we're going to, from TextBlob, import Word. TextBlob is a natural language processing library. We're going to import NLTK, that's Natural Language Toolkit, which has been around for a long time, but it's still being used. And we're going to download StopWords and WordNet. And then from we're going to import sklearn. So from sklearn, we're going to import classification report, confusion matrix, accuracy score, and what that is going to do is going to help you check the goodness of fit of the model, check how well the model actually performs. We're going to import Keras, which is going to create our neural network. And then so from Keras, we're going to import Tokenizer, pad sequences, embedding LSTM dense sequential. And then we're also going to import train test split from sklearn. But what I'm going to do is I'm going to put that over here. And then so make train test split in there with the other sklearn libraries just to keep it all together. And then we're going to import Seaborn as SNS, which is going to visualize our data. So after we have imported our libraries, what we're going to do is we're going to load the CSV file. The CSV file is tweets that I got off of a GitHub account, and it's sentiment analysis. So it's going to be either 0 or 1. So yeah, it's going to be either 0 or 1. So that's your sentiment analysis. Now what we're going to do is we're going to analyze the label. So target is going to be the label from the data set, data frame, and tweets is going to be the tweet from the data frame. And you can see here that when we read in the CSV file, we use pandas to convert it to a data frame. And now we're going to use Seaborn to analyze the target, and you can see that this is highly class imbalanced. Most of the labels are 0, and just a few of them are 1. So this is a very highly imbalanced data set, but that's the data set that I was able to get off the internet. So we're going to do a value count on tweets. So on 0, you've got 29,720, and on 1 you've got 2,242. We're going to check the number of classes in the label, and it's got 2 classes, a 0 or 1. So now we're going to pre-process the text, and then we've got a function to clean the text. So we're going to make all the tweets, join all the tweets together using the join function. We're going to replace the @ symbol with a blank space. We're going to replace the hash symbol with a blank space. We're going to remove the stop words, and then we're going to limitize the tweets. and then we're going to return the tweets after we've done all that. And now what we do is we're going to set up our hyperparameters. So max words is 10,000. That's the maximum words that you can have in the vocabulary. Max length is 100. That's the max length for each tweet. The embedding style is embedding dimension is 100. That's the dimension of word embeddings. LSTM units is 64. That's the number of units in the LSTM player. And we've already defined the number of classes previously, but I didn't want to throw out that piece of code, so I just put a little pound mark on it to make it a remark. So just in case you're working on a data set and you haven't got the number of classes, then you just take the pound mark off and use it. Now we're going to tokenize the text and create a vocabulary. Tokenizer equals tokenizer num words equals max words. Tokenizer dot fit on text tweets. Sequences equals tokenizer dot text sequence tweets. And then X equals pad sequences. Sequences max length length. So now we set the Y variable is the target, but there's another little, if you wanted to make it categorical, like let's say you had more than 2 classes in your label, then what you could do is you could convert it to categorical. But since we only have 2 classes in our label, I just said Y equals target. But I didn't want to throw away that piece of code because it's a good piece of code. So I just made it a remark. We define our X and our Y variables. So we check what our target and our tweets are. So your target is an integer and your tweets are an object. But really what we should have done is we should have done X and we should have done Y, because we've already defined our X and our Y. We've already done that. So we don't need to define the X and the Y because that's already been done. We check our shape of our X and our Y. So our X is 31,962 rows by 100 columns. So, and you notice that your indem, your dimension is 100, I believe. Embedding dim is 100. And then your Y shape is just 1 column of data. So we're going to split the data set for training and validation, and we're going to use sklearn's train test split for that. And then we're going to check our shape of X train, Y train, X val, Y val. Now we're going to build a sequential model, LSTM model. That's the great thing about doing these code reviews. I can, if I find a mistake or something I don't like that well, I can go ahead and correct it during the code review before I write it up. So the model is sequential. Model.add embedding max words, embedding dim, input length, max length. Model.add is LSTM units. Let's see how many LSTM units we've got. 64. Model.add dense is going to have 1. That's 1 because it's binary classification, and activation is sigmoid. Now, if you had like more than 2, if you had more than 2 classes in your label, then it would be number of classes and then softmax. But since I've only got 2 classes, I decided to make it 1 and sigmoid. And then we compile the data, and the loss is binary cross entropy. Optimizer is atom, and metrics is accuracy. So if you had more than 2 classes in your label, then it would have been, the loss would have been categorical cross entropy. So there's always a difference between between 2 classes in the label and more than 2 classes in the label. 2 classes in the label, it's going to be binary with activation as sigmoid and loss as binary cross entropy. And more than 2 classes in the label, it's going to be number of classes. Activation is going to be softmax, and loss is going to be categorical cross entropy. Now we train the model.fit, x train, y train, batch size equals 32, epochs equals 10. So we did it for 10 epochs, and we had 99.88% accuracy. And if we trained it for like 20 epochs, who knows, maybe we would have had 100% accuracy. So if you want to try this code out, you can try it out with 20 epochs and see what happens. But it does actually take a bit of time to train it, which is why I only had 10 epochs. And now we evaluate the model, and it said that we've got accuracy on the validation set, and it said you've got 95.59% accuracy. And then now we make predictions. So when we make predictions, if the value is above 0.5, it's going to be 1. If it's below 0.5, it's going to be 0. So most of them are 0. Now we check the accuracy. We've got an accuracy of 95%. We check we don't need this because we've done the confusion matrix already at the very beginning of the program. But we create a confusion matrix, and you'll see that we do have some zeros and ones. But although on the ones you've got 85 zeros that should be ones, and on the zeros you've got 56 ones that should be zeros. And we can take that out because we don't need that, because that was declared at the beginning of the program. We do a classification report, and the classification report will give you some more information about how well the model has performed. And then we create a data frame so you can compare the zeros and ones. And so that's it. That's it for this particular program. We're going to use LSTM to carry out sentiment analysis. And so I intend to do some more natural language processing, but I decided to do it on this particular data set because I already had it in my Google account, but I plan to do some more to see if I can do it on another library, because this one library that I've been doing stuff on, there's not a lot written on it, and so it's hard for me to find stuff on it. But who knows, we'll see. Maybe I'll get there. So I'm going to go ahead and conclude this video because I've covered the LSTM and natural language processing with Keras. And if you like my video, please like, subscribe, and share. Thank you so much for watching my video. I look forward to communicating with you in the next video that I make.